Okay, this is an extra lecture on what originally would have been problem set 6 on the language Klamath. But I thought it was worth going through because it really shows some interesting facts about stress and phonotactics and syllabification. And yeah, so Klamath is a Penutian language that was spoken in the Pacific Northwest. Unfortunately, we believe that the last speaker of Klamath died in 2003, so it is now a dead language. Um, and that is incredibly sad, but also we got really good documentation of this language in the 1960s and the 1990s in two separate linguistic sketches of the language, which at least we have surviving a description of the language, even though it's apparently no longer spoken. Klamath displays two phonological phenomena that we've studied in depth in this class: positional neutralization of laryngeal contrasts, and weight-sensitive stress. And so the laryngeal contrasts here are not going to be the ones typical of Indo-European languages that we've looked at, which has been mostly voicing, voiced or voiceless. The contrasts here are going to be for aspiration and ejectivity. So at each place of articulation, Klamath contrasts a plain voiceless stop, as in ba, an aspirated voiceless stop, as in pa, and an ejective voiceless stop, as in pa. So there's a three-way laryngeal contrast in Klamath, and it also has weight-sensitive stress of the kind we've just been looking at in Latin and in classical Arabic. So this last homework is going to take a look at each of these phenomena and reach an interesting conclusion. This is all based on a paper from Juliet Blevins in the 1990s. On Klamath laryngeal phonology. So let's first look at the laryngeal contrasts and their neutralization. And this part should be completely review, right? These are patterns that we've seen repeatedly in 411 and this semester as well. And here, what we're looking at again is going to be morphophonological alternation. So we'll take a single underlying representation for a root or a stem and then put it in different phonological contexts and see what happens to laryngeal contrasts, right? So I don't have a complete paradigm here showing you every single stop in every single context, right? So I don't have minimal pairs that are going to show you a labial stop in every single phonological context and how the laryngeal features work out for a plain labial, an aspirated labial, and an ejective labial. Instead, we're going to look at different places of articulation, and you should assume that all the stops pattern the same way with regard to laryngeal features, and that also includes actually affricates. Even though I don't have every single one in every single context, this is a quite general set of facts about Klamath phonology. Right? So what do we have going on here? I've given you the underlying representations over in this left column, and you can see that these underlying representations, including the three-way contrast for aspiration, ejectivity, and plain voiceless stops, these surface in prevocalic position when you get some kind of a suffix on these words that begins with a vowel. So here, the root, I don't even know how to make an ejective nasal. It's going to be something like ape. And that aspiration survives when the following suffix begins with a vowel. Similarly, in check, that ejectivity survives when the suffix begins with a vowel. And in the plain case, the plain unaspirated voiceless stop, ka, that also surfaces faithfully when the following suffix begins with a vowel. So the suffixes here are something like e, a, ani, and am. Right? They all begin with vowels, and what we find is that the three-way contrast for laryngeal features is preserved in this prevocalic position before a vowel. Take away those suffixes, right, and you look at these roots by themselves, and we find that all three of these neutralize to plain voiceless stops. Right? So again, this is going to be a case a little bit like the German and Russian cases that we looked at last semester, where the plain form is not the most informative one. Right? The sort of citation isolation form of these stems is not the one that's showing us the underlying representation. Instead, the underlying representation is only showing up when you can get these final consonants before a vowel in some way. When you don't get them before a vowel, in particular in word final position here, that three-way laryngeal contrast neutralizes. We also saw a pattern like this with a three-way laryngeal contrast in Thai that did the same thing. So what are we seeing here? Laryngeal contrasts are licensed before vowels, but neutralized word finally. That should look pretty familiar by now. And this next bit in 2 should also look pretty familiar. So in word medial clusters of 2 consonants, the possibility of laryngeal contrasts for the first consonant depends on whether the second consonant is an obstruent or a sonorant. So again, looking in pre-vocalic position here, I've singled out one ejective, one aspirated, one plain stop, as well as a sonorant here, just to I think this was mainly actually just to show word initial position here. And so what do we find here? Well, in pre-vocalic position, we find that these final consonants surface faithfully with their ejective and aspirated features. We can also see within the suffix itself here that plain voiceless stops also surface faithfully. Here before this vowel, you can see that p, the aspirated p surfaces faithfully. And so before vowels, again, everything is surfacing faithfully. Contrasts are preserved. With not much more to say about that. Before a sonorant consonant, we find exactly the same pattern. So this ejective stop, this surfaces faithfully before the sonorant glide, wa. This aspirated affricate, cha. Oh, sorry, I got that wrong. That was an ejective. This is aspirated, cha. This surfaces faithfully before a sonorant consonant, a nasal. The plain, voiceless, unaspirated stop surfaces faithfully before a liquid, la. And this word beginning here is just showing you that this is the same thing is true in word initial position. You can get an aspirated stop before a liquid. You can get other kinds of stops before liquids. So it looks like pre-sonorant context works just like pre-vocalic context here. All the contrasts are preserved. What about the cases where you have a consonant cluster and the second one is an obstruent? Well, here's a few examples here. And what we can see is that this voiceless stop, even though in the UR it's ejective, and you can see that the ejectivity surfaces faithfully before a sonorant consonant or vowel, before an obstruent, it instead changes to plain voiceless unaspirated stop here. So interesting. Similarly, this aspirated affricate, which surfaces faithfully before a vowel or before a sonorant consonant, neutralizes to plain voiceless unaspirated before another obstruent. In this case, the second obstruent itself is actually ejective, but the first one is not allowed to be. It loses its ejectivity. Similarly here, there's this prefix kep. I'm not sure exactly what it means, but it only shows up before an obstruent with a voiceless unaspirated stop here. So again, three-way contrast before a vowel, three-way contrast before sonorant consonants, neutralization before an obstruent. And this again, we've seen this several times for different features in different languages throughout 411 as well as the semester. So we saw this pattern where you get contrast before a vowel, contrast before a sonorant, but then neutralization in word final position or before an obstruent. We've seen that for voicing in Russian. We saw it for supralaryngeal features in Slavey, where there's debuccalization. We saw this for nasal places features in Spanish. And we generally talked about this during our syllabification unit because this particular pattern with this grouping of contexts, pre-vowel or pre-sonorant on the one hand, and then word final or pre-obstruent on the other hand, it has a common syllable-based explanation. The contrasts are only licensed in certain syllable positions and they're neutralized in other syllable positions. In the different types of consonant clusters shown in 2 here, these differ from one another because they have different syllable structures. Right? This was one of the most attractive properties of our syllable theory, is that it allowed us to group together the right contexts here and separate them from one another in phonological rules. So the first couple questions here are, in terms of this syllable theory structure that I've just alluded to, where would you say laryngeal contrasts are licensed in Klamath, and where are they neutralized? So take a minute and think about that in syllable-based terms. Where are the laryngeal contrasts licensed? That is this, and this column. And where are they neutralized? This and this columns. How would you describe that in syllable theory? Take a second. It's a very short answer. So the answer I'm looking for there is that if you were just looking at this pattern and came armed with your syllable theory, you would say, well, it's just like Russian or whatever. They're going to be licensed in onset position. Right? So all of these consonants before a vowel are onsets of those syllables that are headed by the following vowel. Similarly, in the presonorant case here, we can have obstruent liquid clusters in an onset, just like in English or Spanish. So toi is a possible onset in Klamath. Chne is a possible onset. Pli is a possible onset. Kli is a possible onset in Klamath. Therefore, these are all onset consonants, and the features are preserved because the contrast is licensed in onset position. What the word final and preobstruent cases have in common, just like in English or Spanish or Russian, is that these are all coda consonants, and in coda position, the contrast is neutralized. So word finally, obviously, the only syllable that a final consonant can be in is the preceding one. And then in these obstruent clusters, the classical analysis here would say, well, the difference between presonorant and preobstruent is that these ones are complex onsets, but these ones can't be onsets. And so the first consonant has to be a coda consonant here. And that's why you don't get licensing of laryngeal features on these first consonants in these cases, because they're codas of the preceding syllable and not onsets of the following syllable. Note also that we can see in the word initial position here that indeed you can have word beginnings in Klamath that have some sort of a laryngeally marked consonant, in this case a aspirated uvular stop, before a liquid. So this is definitely a possible complex onset in Klamath, and so far so good. This works just like what we've seen in more familiar languages. And so the second part of this question was just calling attention to this particular difference, which is super important here, the difference between obstruent sonorant sequences, which are allowed to be complex onsets in Klamath, and obstruent sequences, which are not allowed to be complex onsets in Klamath. So far, part one, everything looks great. This works just like other languages we've seen. Here's where the interesting stuff starts. We're going to look at the stress system now. And this was sort of the take-home lesson of the syllabification unit. The best syllable-based analyses help us tie together facts from several different areas of phonology. So in particular, the Latin stress rule that we looked at earlier in the class was really a great example of this, where you can tie together what kinds of consonant sequences are allowed at the edges of words, and how those consonant sequences pattern internal to words, and you can tie those to where stress is located. So basically, all the facts about word edges lead us to expect in Latin that obstruent clusters will be treated differently than obstruent sonorant ones. The consequences of that is that word medially, in the middle of a word, you would expect obstruent clusters to require the first one to be a syllable coda, while obstruent liquid clusters would not, and therefore the preceding syllable should be heavy before an obstruent cluster, but not before an obstruent sonorant ones. And this is exactly what we find in terms of stress. Those predicted to be heavy syllables pattern with, say, syllables with long vowels, while the predicted to not be heavy syllables don't, right? So in Latin, this worked out beautifully. And one of the main take-home messages from that syllabification unit was that syllabification is a theory, And like any theory, it makes predictions. And what we're going to see now is that sometimes those predictions go horribly wrong and are in fact a clue that syllables are not the right way to analyze all of the phenomena under consideration. So we're going to focus in now on words with only short vowels because in Klamath stress just works differently in words with long vowels in ways that are largely irrelevant to the issues we're discussing here. And so we're going to focus in on words with short vowels only. And here's some very brief summary of how stress works in Klamath. I'm just showing you 2 words of each type, and this should look so familiar that you should instantly be able to tell what's going on here. So far, this data in 3, still nothing bad or crazy or unusual is going on. We're still perfectly happy at this point. And what we can see here is that these first 2 words have anti-penultimate stress. So this is something like stastulach. And I'm not even going to try to pronounce this. It's like kalchichix. I guess I just did try to pronounce it. In any case, these 2 words have anti-penultimate stress. These next 2, chikachkis and sisapcha, these have penultimate stress. So we're seeing a difference between words with anti-penultimate stress and penultimate stress. I've only given you 2 of each type, but you should already be able to see what's going on here. So take a moment and see if you can figure out this pattern. Here's a clue. We've just looked at this several times in this class already. Okay, so what's going on here? Well, in these anti-penultimate stress words, we have the second to last syllable being light, right? So here, the syllable is either going to be tu or stu or something like that. But it definitely doesn't have a coda consonant because there's only a single consonant in between the penultimate and final vowels. Same thing here. That second to last syllable is going to be chi or something like that. And there's only a single affricate consonant here in between the second to last and last vowel. So this is going to be light penult, light penult. Look at the difference with these 2 words. Now all of a sudden we have obstruent clusters in between the last 2 vowels here. So this one has an affricate ch followed by a stopped k. This one has an affricate, actually this one has an aspirated affricate, cha, preceded by a labial stop p. So here we have clusters of 2 obstruent consonants, and that preceding syllable then, in these cases, should be heavy, right? And here it's going to be kach with the ch parsed into the preceding syllable, the k parsed into the following syllable. Here it's going to be sop with the labial stop parsed into the preceding syllable as a coda, and the affricate parsed into the following one. And so what we see here is that just like in Latin and classical Arabic, it looks like in Klamath as well, if the penultimate syllable is heavy, it's stressed. And if it's not, then the anti-penultimate syllable is stressed. So this is sort of striking. We've now seen this exact same stress system in 3 different languages from 3 totally unrelated families. So we've seen this in a Semitic language, we've seen it in a Indo-European language, and now we're seeing it in a Penutian language. So there must be something really special about this stress system. Anyway, that's not the main point here, although it is striking. Here's where we're going, right? And so the right answer to how do we stress words in Klamath is that words in Klamath have penultimate stress if the penult is heavy, otherwise anti-penultimate stress. Right? And in order for that to work, what we're going to have to say is that obstruent clusters of this type can't be parsed as complex onsets. Instead, the first consonant has to be a coda and the second one has to be an onset. Note that this matches up perfectly well with the laryngeal contrast licensing that we saw up here in number 2. We saw here in obstruent sequences, we can explain laryngeal licensing clearly if we assume that these are in different syllables, these 2 sequences of 2 obstruents. So far, this is looking fantastic, right? We've now tied together where stress is located in Klamath with the syllable structure needed to explain laryngeal contrasts clearly and easily. Remember, laryngeal contrasts are neutralized in coda position. These first obstruents are in coda position, therefore they can't bear laryngeal features. They're all plain unaspirated. Um, and then converging on that conclusion, when you get these obstruent-obstruent sequences, you find that the preceding syllable is behaving as heavy, right, in Klamath, which is exactly what we predict, and it's attracting stress. So this is really good so far. And then the last question here is going to be, well, what we said here was that these obstruent-obstruent clusters are different than the obstruent-sonorant ones. These need to be complex onsets. These ones have codas followed by onsets. And we've seen confirmed now in the stress system that indeed sequences like this behave as if the first one's in a coda, and it makes the preceding vowel heavy. Now over here, where we have obstruent-sonorant complexes, we would predict that this first obstruent should not be in the coda of the preceding syllable. It should be in the onset of the following one. Therefore, this preceding syllable should not be heavy and should not attract stress. Here's what actually happens, though. When we have an obstruent-sonorant complex in between the second to last and last vowel, so here it's pla, here it's kwa, and note that this consonant, this uvular consonant, actually bears an ejective feature, so it definitely has to be an onset position according to our theory of laryngeal licensing. And same thing here, even though this happens to be voiceless unaspirated, we would still say that it's an onset position based on laryngeal licensing facts. Yet for the purposes of stress, these words have penultimate stress, meaning that they're behaving as if their second to last syllables are actually heavy. What does that mean? Well, in terms of stress, the only way to get this to work is to assume that the penultimate syllable here is heavy, that it's kap. The penultimate syllable here should be heavy. It should be pak. Right? And this is, to put it mildly, problematic. This is the exact opposite of what we had to assume when we were using syllable theory to explain laryngeal licensing. There we said that laryngeal contrasts are licensed in onset position and they're neutralized in coda position. Here we're seeing that in order to get the stress analysis to work, you need to put these consonants, which actually contrast for laryngeal features, into coda position. So what's happening with Klamath is that we have sort of one theory of syllables that we're building on the basis of laryngeal phonology, and another theory of syllables that we're building on the basis of stress. And we did this in Latin, and fortunately, the two theories of syllables developed in these two different parts of Latin grammar agreed with each other. And that was strong evidence that syllables are a useful device for analyzing Latin phonology. In Klamath, that's not what's happening. Instead, we're getting the data from laryngeal contrasts giving us one theory of syllabification, and the data from stress giving us a different theory of syllabification that are inconsistent with one another. In other words, it looks like the notion of syllable that's useful for doing laryngeal phonology is not the same notion of syllable that's useful for doing stress in Klamath. And that raises the question of whether we actually want syllables at all to do Klamath phonology. If they're really not giving us the same conclusions about structure in different areas of the phonology, that seems a little bit strange. We'd have to say something like, well, Klamath has a stress syllable and it has a phonotactic syllable, and they're totally different from one another. And that is not attractive as a theory of hidden phonological structure. At that point, you might be better off just talking about these two domains of phonology without reference to syllables at all. So the point of this exercise was to show you that, hey, often syllables are helpful and they help us do useful things in phonological analysis, but they're not necessarily always the right tool, and there's disagreement about the extent to which syllables are relevant to different kinds of phonological phenomena. So this is just showing you that sometimes syllable theory is quite problematic and doesn't make the right predictions. We also saw some examples of this for Spanish phonotactics earlier in the semester, and this is the same type of lesson, although obviously very different area of phonology here. So that is the Klamath problem.